All right, let's get into section 5.1, where we're getting into rational numbers in chapter 5, right? And a rational number, you can think of that as a fraction, okay? Anything that can be written as a fraction is considered rationals, okay? Today we're going to be looking at writing fractions as decimals. Okay, so our learning target is to write fractions as terminating or repeating decimals, and we'll talk about what each one of those looks like. And then we want to compare fractions and decimals to get relative size. Which one's bigger? Are they equal? So we'll be using greater than or less than notation. So first off, our key terms, a terminating, right? Terminate means to end. Okay, so a terminating decimal is one that actually ends. Okay, so in division, when the remainder ends up being zero, that is a terminating decimal, right? So if I have 1/4, we should know that that is 0.25, right? If I type that in my calculator, I can see that it ends at 0.25. Another decimal, let's say 0.451, is a terminating decimal, right? And that can be written as a fraction because I can always say, all right, well, there's 451. This is tenths, hundredths, thousands. So it's 451,000. So I could put that over 1,000, all right, and that's the fraction form of that. Same here, right? I could say 0.25 is equal to 25. This is tenths and this is hundredths. So 25 100ths, right? And then that can reduce to 1/4, right? So that's where that comes from. We also are going to be working with mixed numbers, okay? A number that contains a whole number and a fraction, right? This would be read as 3 1/2, right? Which can be separated to 3 plus 1/2. And we'll also be looking at how do I turn 3 1/2 into an improper fraction, right? And just refresh on that. That means I'm divided into two. So 2 times 3, right? So we multiply here, right? So that tells me how many halves are in 3, right? 2 times 3 is 6. So this part represents 6 halves. Plus, I have this 1/2, which would give me 7 halves, right? So 3 1/2 is the same as 7 halves. So we'll be looking at that mixed numbers and going back and forth from improper to mixed. We'll also look at repeating decimal, okay? When division doesn't end in a 0 and a pattern repeats, right? You probably have seen 1/3, right? Which is 0.3 if you plug it in your calculator. It's just 0.3 and it goes on and on and on and on until your calculator stops, right? Your calculator has a finite number of spaces, but that pattern would continue. Now, to represent the repeating pattern, we use what's called bar notation. So 0.3, right? I get my calculator, and this pattern keeps going on. The notation for that is 0.3 with a bar over it. Okay. Now we got to be careful because 0.3 is different. It's not equal to 0.3 bar notation. Those are not the same. This bar indicates that this pattern continues. Okay. So the 0.3 and the 0.3 with the bar over it are not equal. This is bigger. This is like 33 if you're talking about 33 1/3%, right? That keeps going on. This is just 30%. So that's what the bar notation, it implies that that pattern continues on. Now, one thing you'll see in your calculator, right? If I were to type in 2 divided by 3, right? Which is 2/3, right? 2 divided by 3, 2/3, same thing. My calculator is going to say 0.6666666, and then it runs out of space and it rounds that next one to the 7. Okay. The 3 doesn't round, so it stays as a 3, but the 6 that's really here rounds that up to 7. There's no more spaces on your calculator, so that's what that looks like. If I wanted to represent, I can see that my pattern is a 6 that's repeating. So I would say that that is 0.6 with the bar over top, which means 0.6 repeating. All right, so let's look at some terminating decimals and how do we take this fraction and turn it into a decimal. All right, and I'm going to show you the non-calculator way, just so you understand what's going on. Right, 1/4 is the same as 1 divided by 4. Right, so if we're going to do long division, right, I have this 1, and I'm going to divide that by 4. Now we know that 4 doesn't go into 1. Right, so I'm just going to write some zeros here. I'm going to put that up top. I know that 4 doesn't go into 1, so I could write a 0 here. Okay, and that should make sense. It's less than 1, right? 1/4 is less than 1. So then I'm going to say, well, how many times does 4 go into 10? And that goes in there twice, right? 2 times 4 is 8, right? Drop that down, right? We subtract there. That's 2, drop the 0. 4 goes into 20 5 times, right? 5 times 4 is 20, and there's my remainder of 0, right? And that's the same thing, right? 0.25 and 0.250 is the same thing, right? But your calculator doesn't put those zeros there. So 0.25 is that method. Now, method 2, right, is to take your calculator and type in 1 divided by 4, and you hit equals, and it tells you 0.25. Now, we should be able to do method 1, right? You learned about that in previous math classes, how to do long division, and I know it's been a while, but I want you to try the long division method with number 2 and 3 real quick. Okay, we'll do that, and then I'll show you the Desmos and some features that has. So pause here, right, and you're going to do 3, and you're going to divide that by 8. And then over here, you're going to take 17 and divide that by 20. All right, so take a minute and see if you can do that. Pause the video and then check back. All right, so let's check your work here. When we took 3 and divided it by 8, okay, when I took 3 and I divided it by 8, so I did 3.000 to start, right? 8 goes into 30 3 times. It was equal to 24. 30 minus 24 was 6, right? I dropped the next line, which is 0. 8 goes into 67 times. 7 times 8 is 56, right? That was a difference of 4. Drop the next 0, right? I'm not done yet. Right here, I was done after 2. Here, I'm not done because I have this 4, so I dropped the 0. 8 goes into 45 times, right? That's equal to 40, so there's our remainder of 0. I'm done. I know that that is the terminating decimal, right? 0.375. In the next one, 17 divided by 20, right? So I put the decimal after the 17, right? 0.0, right? Because 17 and 17.00, same thing, right? We're just adding spots for division. So 20 goes into 178 times. Okay, that's equal to 160. When I subtract that, I got 10. Okay, and then I had to drop that next 0. 20 goes into 105 times, remainder of 0. So I know that that's 0.85. All right. Now, if you don't have a calculator to use, right, Desmos is a nice calculator, right? I can come over here and I can type in 1 divided by 4, right? And we get 0.25, tells me that there, right? I can type in 17 divided by 20, right? And there's my 0.85, right? And then we had our 3 divided by 8. Okay, now when you start typing things in, you have this little button that pops up. Okay, and that's a fraction. So I can change my answer here to a fraction. You see it goes from 0.25 to 1/4. And that's nice as you go through. Sometimes you'll do a problem and you want your answer in fraction form. All right. And so you can click that over there, right? So for example, if I did plus 1 divided by 2, I get 3.5. If I want that as a fraction, right, I can do that. It gives me an improper fraction of 7/2. So let's go back here. So that's method 2, right? Using your calculator. And I get it. You guys will do that and use your calculator. More apt to do that than do the long division. But you should know how to do the long division, and you should understand that that's where that comes from. All right. Now, some fractions you should recognize, like 1/4, a quarter. You should know that that's 0.25, right? You should also be able to relate it to percent. Okay. And so one way to think about that is there's some denominators that go into 100, right? And our percents are based off of 100. So, for example, I know that if I multiply 20 times 5, back that up. If I multiply 20 times 5, I get 100, right? Well, if I multiply 17 by 5, I get 85, right? And 85 out of 100, 85%, right, is 0.85. 8 doesn't go into 100 evenly, so that method here wouldn't be beneficial to use, right? But 4 certainly does, right? 4 times 25, right? If I multiply that by 25, that gives me 100. And then 1 times 25 is 25, right? 25 out of 100 is 0.25. So that'll help you recognize, right? So for example, the easy ones, 2/10, right? If I times that by 10, times that by 10, so 2/10 should be 0.2 on your calculator, right? Or 0.20. Those are the same thing. All right, writing mixed numbers as decimals. All right. So mixed numbers just means that I have this whole and I have a rational or a fractional part, right? So that's really 3 plus 1/2. So to turn that into a decimal, I know it's going to be 3, and then I got to figure out what decimal part does this represent. And hopefully we know that a half is equal to 0.5, right? You got 1/2, 2 out of 4, 3 out of 6, right? If I want to get that all the way to 100, it would be 50 out of 100, right? 50 out of 100. Okay, so that's 0.50, right? 50, and this is tenths, 100. So let's talk about that real quick, right? The decimal place, and this is tenths, right? This one would be hundredths, right? This is thousandths, right? And if you go here, we have ones, tens, hundreds, thousands, right? Going the other way. So 5/10, right? If I just write that out, 5/10, right? What does that reduce to? 1/2. So that's why that decimal is that there. So here we have 4 plus 7/8, right? So I know that my answer is going to be 4 plus this 7 out of 8, right, which is less than 1. So I could do the longhand method, or I can come over here. Right, let me clear some of these out. Right, and I know that the 4 is the whole. If I just type in 7 out of 8, I get 0.875. So here, this would be 4.875. All right. Now, another way to do that would be to change it to an improper fraction, right? change it to an improper fraction. So remember, here's my denominator. That's how many eighths we have. Okay, so if 4 was divided into eighths, right, I can multiply there. There would be 32 of them. So 32 over 8, right, that's where the 4 comes from. And then plus we have this, right, so we multiply here. We plus this top, right, because so I have 32 over 8, that represents a 4, plus I have these 7/8, right? So 32 plus 7 would be 39 over 8. So if I wanted to go to my calculator and type in 39 over 8, right, that gives me, because remember up here we just did the fractional part. This was really, we had 4 plus, oh, that didn't do what I wanted it to. So we had 4 plus 7 over 8, right? So those are the same thing. So that's two ways you could do it. If you want to just type it in your calculator all at once, change it to an improper. So what I want you to do is I want you to pause the video here, do 3 and 4. I want the decimal, right? And then so this would be 1 point something. And then I want the improper fraction, right? Something over 10, right? Obviously something bigger because it's more than 1. All right, so do that for number 3 and 4. Pause the video and then check back. All right, let's check here. So number 3, 1 and 7/10 is 1.7, right? Which should make sense because if I read this, right, 1.7 is really 1 and 7/10, right? This is the 10th spot. And improper fraction, right, would be 17 over 10, right? This is what we're doing today, but you will want to know how to get that value there, because later on in the chapter, we're going to be getting into multiplying and dividing rationals, so we'll have to change them to improper fractions. Number 4, -9 and 1 over 20, right? So -9.05 is this right here, and just to make sense of this, right? -9, and this would be tenths, hundredths. This would be -9 and 5/100ths, right? And let's just think of the fraction part here, 1 over 20. So if I times this by 5, right, there's my hundredth. If I times the top by 5, okay, 5/100ths. That's where this comes from. And if you were going to change it to an improper fraction, it would be -181 over 20. All right, repeating decimals. Okay, repeating decimals. These are decimals that do not terminate. However, there is a repeating pattern to them. All right, so let's start with the first one, right? And we're going to take 1 and we're going to divide that by 3. So I'm going to start, I'll put some zeros over here, raise my decimal up, right? I know it's going to be less than 1, right? Because 3 doesn't go into 1, okay? But 3 goes into 10 3 times, okay? 3 times 3 is 9. And subtract those values, drop the next digit. 3 goes into 10 3 times. 3 times 3 is 9. Subtract, right? Drop the next one. 3, and you can see that I'm getting this same, and that'll keep going on no matter how many zeros I add, right? I'm still going to be getting this loop here of, right, -9. How many times does 3 go into 10? And so that just keeps going. So the repeating decimal, remember, write it in bar notation. That 3, right, this is the period it's called because that's the repeating value. That just keeps going and going, right? And if you type it in your calculator, that's what you'll see. 9s are a pretty cool pattern. So if we look here, and this might be another one you memorize as well, right? 1/3 should be recognizable, right? 2/3, right, would be 66 or 6 repeating. Um, so if we look at ninths, all right, so I'm going to take 2 and divide that by 9, right? So I'm going to put my zeros here, put my decimal up, right? 9 goes into 2, does not, right? And I can see that that's less than 1, so that should make sense. 9 goes into 20 twice. That equals 18, right? Subtract them, right? We see our pattern hopefully already. There's my 18. Get a remainder of 2, drop the next 0, okay? And I get that going. So that is just a repeating pattern, right? And what's kind of cool is if you look at the pattern of dividing by 9, 1 divided by 9, look at that, 0.1. We just did 2 divided by 9, right? Now 3 divided by 9, whoops, 3 divided by 9, right, is 0.3, which should make sense because 3 divided by 9, right, if I reduce that, it's the same as 1/3, right? So you should be able to guess what is 4 divided by 9, right? 0.4 repeating. 5 divided by 9. Okay, and now I want to show you this because 5 divided by 9, 0.5 repeating. Look what happens with this last digit there, right? My calculator runs out of space right here. Okay, this is really a 5, and the next one's a 5, and the next one's 5, but my calculator doesn't go past. It takes what's next, which is a 5, and it rounds it up to 6. Okay, so that is still a repeating pattern, right? 6 divided by 9 should give me the same as 2/3, right? That 0.6 repeating. All right, so you can see the nines pattern there. And again, right, you should know how to do it longhand. You should know where that is, right? But we have these sweet technology tools called calculators that will help us out. So when I have this -6/11, I know that my decimal is going to be a negative, right? And so if I come here to my calculator, I can type in -6 divided by 11. And so if I look at that, it's not just a single digit pattern, right? It's not 0.3 repeating or 0.2 repeating. It's 0.54 repeating. And notice that it rounds at the end because I run out of space. So my calculator tells me 0.5. Oh, terrible with fives here. All right, so 0.545. I have to put in problems that don't require a 5. 5, 4, 5, 4, and so on, right? So my period, right, is 5, 4. That's what's repeating. So to write my answer in bar notation, it's -0.54, and that's what's repeating. So I put that bar over top. That implies that it is repeating 5 4s, right? 2/15. So if I come down here, 2 divided by 15. So it is 0.13 repeating, right? 0.13 repeating. So that one starts with a different value, the 1, and then it has this repeating pattern of 0.3. So my calculator tells me 0.133333, and so on. So if I'm going to write this with bar notation, 1 is not part of the repeat, okay? But 3 is, okay? So the 3 is the only part that has the bar over the top of it because the 1 doesn't repeat. That's telling me that I have 0.1 and then the 3, and the 3 just keeps repeating. So make sure that bar doesn't go over both of those. Now, comparing, right? And we use number lines to do that. Now, when we compare fractions to decimals, okay, it's easiest if we get them in the same form. Okay, it's easiest if we get them in the same form. And it's easy to compare decimals. Okay, fractions are somewhat confusing without visuals, but we should be able to compare decimals pretty easily. All right, so what I want to start by doing is change anything that's not a decimal. Okay, so here this is 0.6, right? If you type that in your calculator, it's 0.6. Okay, 6/10, right? So if I want to get it to tenths, right? If I times 5 by 2, I get 10. If I times 3 by 2, I get 6, right? That's 6/10. So that's what that looks like as a decimal. Well, I'm comparing that to 0.62. Well, if I want to compare numbers, right, I just add a 0 so I can match those two up. So I got 0.60 versus 0.62, right? And if I think in terms of percent, 62 is a better percent than 60. So if I'm going to compare these two, the 0.62 is greater than, right, is bigger than 0.6. All right. Here, 0.3 is already a decimal. And 1/3, we've already done that one. It was 0.3, right? Repeating, right? So 0.33, and I can change that to 0.30, right? We can say that that's repeating. So 30% versus 33%, okay? 33 is greater, all right? Now, with negatives, okay, it's a little bit more confusing, right? Because, and I might want to look at my number line to help me out. So here we have negative 0.5, right? And I'm just going to write negative 5 over 8. Type that in your calculator if you wish. That's going to give you 0.625, right? So I'm going to just add a couple zeros so we have that size. So it's negative 0.500 to negative 0.625, right? 625 versus 500, right? And the easy thing to say is, oh, this one's bigger. However, think about negatives, right? When we number them on a number line, right? If that's 0 and that's negative 1, right? Negative 0.5, uh, negative 0.5 is right here, right? So if I start from 0, this would be negative 0.1, negative 0.2, negative 0.3, negative 0.4, negative 0.5. Negative 0.6 is here, and a little bit more than that is negative 0.625. So, right, remember when we look at a number line, the further left you go is small, right? And the further right you go is bigger. So when I look at this, the negative 0.5 is actually greater than the negative 0.625. So you got to be careful with your negatives, right? If you want to use your number line to assist you there, make sure you do that. And then think about it as owing. Would you rather owe 625 or would you rather owe 500? Right? I'd rather owe 500, which means that's a greater value than the negative 625. Here we have negative 0.34 with a bar over top, right? Which means that that's going to repeat. If I type in negative 34 divided by 99, I get that same negative 0.34 repeating, right? These two values are equal. Okay, these two values are equal. Now it says to list these from least to greatest. So I want to start with my smallest value. Okay, so if I look up there, my smallest value would be the negative 625, right? And I say that 625, that's not, it's 0.625. Okay, so that is the smallest. Now, if this were an answer key, right? So I know that the negative 0.625 is the smallest. But my answer key wouldn't say that because this is the value they gave me. I changed it to a decimal so that I compare it. So on the answer key, it would say that negative 5 over 8 is the smallest. Okay. And then next we have, right, and I have here the negative 0.500. Remember where that came from, the negative 0.5. Try that again. Negative 0.5 is next, right? These two are equal. So I'm going to write the negative 0.34, the bar over it, and negative 34, right? Negative 34 over 99 in the same level there because those were equal. Now getting into the positives, right? Next up was the 30, right? So the 0.3, right? 30%. And then we had 33%, right? Which was actually 1/3 in the original problem. We changed it to a decimal. Next up, we have the 60%, the 0.6, but remember that came from 3/5. And 62%, which was 0.62. So remember, when you're ordering, you start with the farthest left on the number line and work your way to the right. So there's section 5.1. All right. I would like you to start practicing the problems on page 203. You can see the numbers there. Note, you do not have to use a calculator, but I would practice a few of them as long division, right? Just so you're good with that. If you have any questions, please shoot me an email. I hope you have a great day.